So far, we've worked with f prime, and f double prime. We're also able to work with the integral of the antiderivative of f, and that's what we're doing in this lesson. So we're told that we have some function f, and we're told that g of x is the integral of f of t dt from 0 to x. This 0 to x is going to be useful in later lessons because it allows us to fill in the positive and negative line for g of x, because remember, normally here we don't have a translation for positive and negative for the integral. It doesn't, just as in general, this line doesn't have a translation to the left. And in later lessons, we're actually going to be able to create that line using this information. But for now, we're just going to be asked about things like inflection points and increasing, decreasing that we can find out from looking at the graph of f. So let's start off with our usual f. This is t. This is t just so that these variables are different. It operates just like the x does. And we can find out all of these things. Let's see what we need. So we know that g of x is the integral. So we are translating this way. There is no translation for concavity. This is increasing, decreasing becomes concave up, concave down. Plus minus becomes increasing, decreasing. Okay, we are asked about the relative or local minimum. So that means we're interested in this line right here, and so we need to fill in this line. The rest of them are optional. So this is positive until -5, and then it's negative until -1. And then positive again. So g of x, increasing, decreasing, increasing. We are asked about the relative or local minimum. So that's right here when g of x changes from decreasing to increasing. So we would say that g of x has a relative or local, same thing, minimum at x equals -1, because f of x, which is its derivative, changes from negative to positive. And there we go. So this is really just the same thing that we've been doing. It's simply that this notation looks a little bit different. All you need to know for these to use everything you've already learned is that instead of going from here to here, we're being given this, and we're going to this. So same as before, if we have a graph, we can also be asked about not just this line, but also this line. So g of x having an inflection point is going to be on this one right here. So that means we need this line filled in, increasing, decreasing. So -3, it's decreasing until -3, increasing again, flattens at 2, but then is increasing afterward. Oops, should probably show you how to do that. Okay, decreasing to -3, increasing to 2, increasing again after 2, even though there is a horizontal tangent line at 2 itself. So that means concave down, concave up, concave up. There's only going to be one inflection point because there's only one change right here at -3.